Section 7.7 is about mathematical modeling with quadratic functions, and we have two objectives. One is to solve minimum maximum problems involving quadratic functions, and second, to fit a quadratic function to a set of data to form a mathematical model and then solve related applied problems. So let's begin with a basic discussion of maximum minimum problems. And so we see that any quadratic function has a form f of x equals ax squared plus bx plus c. The value of f of x at the vertices is either, at the vertex rather, is either maximum or minimum, meaning either all outputs are smaller than the values for maximum or larger than the value for minimum. And so here's the graph of it. So here we have, for the case where a is greater than 0, we have an upward opening parabola. And so here the vertex indicates a minimum. F of x would be the minimum at this point. On the other hand, when a is less than 0, we have a downward opening parabola. And so the vertex here would be a point of maximum. So here we have a stained glass window, and an artist is designing that with a perimeter of 84 inches. And the question is, what dimensions will yield the maximum area? In other words, what length and width will yield the maximum area? Here's width and length. And so when we choose some values for L and W, 10 times 32 is obviously 320 square inches. A 12 by 30 gives us 360 square inches, and so on. Of course, for each case, we have to have that 2 times the length plus 2 times the width has to equal 84. Other than that, we can choose any values for L and W. Now the area is equal to length times the width, that's equal to A. Or in other words, solving this equation for W, W is equal to A divided by L. When you substitute this value for W into the original equation, we find we have 2L plus 2 times W, or 2 times A divided by L, equals 84. To eliminate the denominator, we multiply both sides by L. So we get 2L to the second power plus 2A equals 84L. Subtracting 2L squared on both sides gives us 2A equals minus 2L squared plus 84L. And to simplify these calculations, let's just divide, write it this way: 2A equals 2 times minus L squared plus 42L. We divide both sides by 2. So A, the area, is equal to minus L squared plus 42L. So in other words, now we have the area as a function of length. So roughly speaking, it's going to look like this. We have L along the horizontal axis and the area here. And so we can kind of, it's a downward opening parabola which begins at 0 because if L is equal to 0, A is equal to 0. So it's going to look like this. And so we are looking for the vertex. And we know that the x-coordinate of the vertex, the L-coordinate of the vertex, let's say L sub v, is minus b divided by 2a. And so that's minus 42 divided by 2 times minus 1, or 21. So in other words, here we have 21. And when we substitute that for the area, then we find that f, or when L is equal to 21, then A is equal to minus 21 squared plus 42 times 21, and that's equal to 441. So 441 is here. And since this is the line of symmetry, we have the vertex at this point. So the vertex has coordinates 21, 441. And so when L is equal to 21 inches, so L is equal to 21 inches, then W is equal to A divided by L, or 441 divided by 21, and it's equal to 21. So the dimensions of the stained glass windows is the length equals 21 inches rather. 21 inches, and the width is also 21 inches. So in other words, it's a square picture, square stained glass window. Again, the important equation is this one here, where we have the area as a function of length. Again, it's a quadratic function. It's a downward opening parabola. So this is A equals minus L squared plus 42L. The second part of the section is about fitting quadratic functions to data. And so here we have a table of data. We refer to ticket profits. There's a community college that's presenting a series of plays, and the profit P in dollars after X days is listed in the following table. So days in terms of X is 0, 90 days, 180 days, 270 days, 360 days, and 450 days, and then the corresponding profits. And of course the minus sign means a loss, and then the positive numbers. The first question is make a scatter plot of the data. So we did that, and the scatter plot of the data looks like this. And then the question is decide whether the data can be modeled by a quadratic function, and it certainly looks this way. If you look at this, it looks at a downward opening parabola. So there would be the answer to part B would be yes. And then we asked to use the data points 0, minus 100, 180, 872, and 360, 548 to find a quadratic function that fits the data. So let's do that. Let's do the C part. Next, let's use the data points to find the quadratic function that fits the data. So we begin with f of x equals ax squared plus bx plus c. And using the first data point for x equals 0 and f of x being minus 100, we get, so this is for 0, minus 100, we get 0, no, rather minus 100, the function value equals a times 0 squared plus b times 0 plus c. That's the first one. And then for the next data point, for 180 and 872, we have 872 the function value, equals a times 180 squared plus b times 180 plus c. And for the third data point, 360, 548. We have 548 equals a times 360 squared plus b times 360 plus c. So here we have our three equations and three variables, a, b, and c. And so let's do some simplification. First of all, from the first equation, we find that c equals minus 100. Then the second equation, let's multiply out the squares and rearrange the coefficients and the variables. So then the second equation, we have 872 equals 32,400 A plus 180 B. And since C is equal to minus 100, we now write minus 100. And then the third equation is 548 equals 129,600 A plus 360 B minus 100. And now when we add 100 to both sides, we get 972 equals 32,400 A plus 180 B. And then when we add 100 to both sides in this equation, we get 648 equals 129,600 A plus 360 B. So now we have two equations and two variables, a and b. And we can probably solve this by elimination very easily. We multiply the first equation by -2. So we get minus 1,944 on the left side, and then we get minus 68,400 A minus 360 B, and when we add these two equations, we get minus 1,296 equals 61,061. We add these three, the last two equations here. We get 61,200 A, and then 360B minus 360B is obviously 0. So to isolate A, we divide both sides by 61,200. So A is equal to minus 0.0212. And so A is approximately equal to minus 0.02. When we substitute this value for A in any one of these equations, maybe this equation here, because the numbers are smaller, we find that B equals 9. So therefore, the function f of x equals A is equal to minus 0.02, so minus 0.02 x squared plus 9x, and remember c was equal to minus 100. So that is a quadratic function that models the three data points that we were supposed to select. The last part asked us to evaluate the function when x equals 225. So f of 225 equals minus 0.02 times 225 squared plus 9 times 225 minus 100, and that is equal to $912.50. So $912.50. And this was the answer for the C part. Based on the calculations I did here for you. So here's an example of maximization. Economite Plastics plans to produce a one-compartment vertical file by bending the long side of an 8-inch by 14-inch sheet of plastic along two lines to form a U-shape. How tall should the file be in order to maximize the volume that the file can hold? So here's the original sheet, 8 by 14 inches. So then this height would be x, and of course this height would also be x. And since this represents the length, then so this is again x as well. And since the whole sheet is 14 inches long, then this distance here is 14 minus 2x. 14 minus 2x. The whole length is 14 minus x twice, so it's 14 minus 2x for the remainder here. The other thing we know is that this distance here is 8 inches. It's 8 inches long. 8 inches. So then the volume is equal to 8 times, that's the length, times the height, x, times the width. And the width is 14 minus 2x. So that then is v equals 8x times minus 2x is minus 16x squared plus 112x. 8x times 14 is 112x. So here we have a quadratic function, and it represents a downward opening parabola since the coefficient is negative. So it approximately looks like this. Here's a volume, is a function of x. And so it starts at 0, it has a maximum, and goes down. And so here is the vertex at this point here. So here's the x-coordinate of the vertex. And so we know that the x-coordinate of the vertex is equal to minus b divided by 2a. And so b is equal to 112, so minus 112 divided by 2 times minus 16. That's equal to minus 112 divided by minus 32. So that means x equals 3.5 inches. So that's how high it has to be bent up. For the next exercise, we have a corral design. A rancher needs to enclose two adjacent rectangular corrals, one for sheep and one for cattle. If a river forms one side of the corrals and 180 yards of fencing is available, what is the largest total area that can be enclosed? Well, the area would be 180 minus 3x times x. So the area equals x times 180, length times width, 180 minus 3x. That means a is equal to minus 3x squared plus 180x. So here we have the area as a function of x as a quadratic expression, and a graph or a sketch would look somewhere like this. So here along the horizontal axis is x, and this is the area as a function of x. So it begins at 0, and it rises to a maximum, and it goes down. It's a downward opening parabola because of the coefficient of x squared. It's negative. So we know that this, at the vertex, we have the coordinate, the x-coordinate of the vertex, and the x-coordinate of the vertex is minus b divided by 2a. So we have minus 180 divided by minus by 2 times negative 3. So that's 1 minus 180 divided by minus 6, or 30. So in other words, for x equals 30 yards, we maximize the area. Now the area itself is equal to this expression here, so it's equal to 30 times 180 minus 3 times 30, or 30 times 180 minus 90, or the area is equal to 30 times 90, or 2,700 square yard. So that's the largest possible area for 180 yards of fencing. The next exercise brings up the question, what is the maximum product of two numbers whose sum is 22? What numbers yield this product? So we know that let x and y be two numbers whose sum equals 22, and then the product p is equal to the product of these two numbers for x times y. Solving the first equation for y is equal to 2 minus x. We substitute this expression for y into the second equation, so it's equal to x times 2 minus x, or p is equal to minus x squared plus 2x. This represents a downward opening parabola, and we know that the vertex of the parabola is at minus b divided by 2a. So in this case, b is equal to 2, so minus 2 divided by 2 times negative 1. Excuse me, rather minus 22 divided by 2 times minus 1. So it would be minus 22 divided by minus 2, and it would be 11. Of course, when x equals 11, then y equals 11. So the numbers are x equals 11 and y equals 11. And the product would be 121. 11 times 11. So we begin with f of x equals ax squared plus bx plus c. And for the first point, we have 4 equals a times 1 squared plus b times 1 plus c. For the second point, we have minus 2 equals a times minus 1 squared plus b times negative 1 plus c. And for the third point, we have 13 equals a times 2 squared plus b times 2 plus c. So that means we have a squared, now a plus b plus c equals 4. And this equation gives us a minus b plus c equals negative 2. And the third equation gives us 4a plus 2b plus c equals 13. And when we solve the system of equations, three equations in 3 variables, we find that a is equal to 2, b is equal to 3, and c is equal to negative 1. So the function will be f of x equals 2x squared plus 3x minus 1. To find a quadratic function as fits the following data, again we begin with f of x equals ax squared plus bx plus c. And then for the first data point, we have the function value is 100 equals a times 60 squared plus b times 60 plus c. And for the second one, we have 130 equals a times 80 squared plus b times 80 plus c. And for the third one is we have 200 equals a times 100 squared plus b times 100 plus c. In other words, we have 3600a plus 60b plus c equals 100. And we have 6400a plus 80b plus c equals 130. And here we have 10,000a plus 100b plus c equals 200. So here we have 3 equations in 3 variables. That's a 1, by the way, 10,000. And when we solve this equation in 3 variables, we find that a equals 1 divided by 20, b is equal to minus 11 divided by 2, and c is equal to 250. So then the function that fits the given data, f of x, or a of x rather, the accident, would be equal to 1/20 s squared minus 11 divided by 2s plus 250. Excuse me, A of s. And then for A of 50 would be 100 per 200 million kilometers driven. This concludes section 7.7.